Okay, for this question, find the particular solution for the following differential equation by using initial value condition. So it's not mentioned whether this one is from what types. Okay, so we only know that this is from first order. Okay, so for the first order, you have learned separable, homogeneous differential equation, linear differential equation, and exact differential equation. Okay, so separable differential equation means that we can separate the variable. Okay, homogeneous differential equation means you have to test the homogeneous differential by substitute f lambda x lambda y. Okay, means that when you substitute lambda x lambda y, you can get back your original question. Linear differential equation must be in the form dy over dx plus pxy is equal to q of x. Okay, so linear, it must be in the form dy dx plus pxy power 1, y must be power of 1, and your right hand side in terms of variable x or any constant. Exact equation, we must have m dx plus n dy is equal to 0. And one more thing, you have to test exact. Del m over del y is equal to del n over del x. Okay, so from this question, you have to determine by your own whether that one is separable, homogeneous, linear, or exact. Okay, so you can see here, this is y power of 3. So, should know that this is not a linear differential equation. Why it is not the linear differential equation? Because linear must be power of 1. This one power of 3. So this is not linear. So we cancel out the linear. Okay. So homogeneous. Homogeneous means that you have to test for the lambda x, lambda y, and then you will get back your original question. So if you test, you cannot get the original question. Okay, so you can try by your own. So this is not the homogeneous differential equation. The same thing for the exact differential equation. When you test for the del m del y is equal to del n del x, that is not the equal term. So means that this is also not the exact differential equation. So this is the separable differential equation because we can separate the variable. Okay, so let us try to separate the variable. Okay, so for the first step, you have to separate the variable. X on right hand side, y on left hand side. Okay, so here you have the dy over dx on the left hand side. So you have dx at the bottom side, you have to bring to the right hand side. So dx at the bottom, bring to the right, will become multiply square dx. Okay, and now on the right hand side, you still have negative y cube. This one bring to the left hand side, will become divide. Negative 1 over y cube dy is equal to x over 1 plus x square dx. Now you have to integrate both sides. Okay, integrate both sides. You have to determine what method that you have to apply in order to integrate negative 1 over y the power of cube. So if you have only one variable that is not multiply or divide with anything, so that one you have to integrate by using direct integration. If you refer to the right hand side here, you have x divide with the 1 plus x the power of 2. You have one highest power here. So you have to know what method that you have to use if you have one highest power. Okay, which is this one, you have to integrate by using u substitution. Okay, on the left hand side, when we want to integrate by using a direct integration and you have power at the bottom side, you have to bring power to the upper side. So y cube bring to the upper side will become y the power of negative 3. So integrate negative y negative 3 is equal to integrate x over 1 plus x square dx. Okay, integrate this one. Negative y to the power of negative 3 will become negative y negative 3 plus 1 over negative 3 plus 1 is equal to integrate x over 1 plus x square by using u substitution. So you must have u. We choose something with the highest power, which is 1 plus x square. 1 plus x square. Du over dx is equal to 2x. So therefore, dx is equal to du over 2x. Why you have to obtain the dx here? Because we want to substitute to the position of dx. So now substitute the whole thing into the terms that you want to integrate. Integrate x over 1 plus x square. X here at the upper side, there is nothing that you have to change. X over 1 plus x square will become u. So x over u, dx here will become du over 2x. Du over 2x. Okay, the left hand side, we already integrate. Negative 3 plus 1 will become negative y negative 2 over negative 2. Integrate the right hand side, x over u multiply with the du over 2x. So you have x here and you have x at the bottom side. So we can cancel out the x and you have constant 2 here. Constant bring to the outside means that we will bring 1 over 2. 1 over 2 integrate 1 over u du. Y negative 2 over negative 2. Negative and negative can be cancelled out. Cancel out the negative. And this y negative 2, we can change the position to the bottom side. 1 over 2y square is equal to 1 over 2 ln. Okay, so from the above, we let u is equal to 1 plus x square. So you have to substitute back this u into the position of ln u. Okay, 1 over 2y square is equal to 1 over 2 ln 1 plus x square plus with c. So this is the general solution. So from the original question that you are given the condition y0 is equal to negative 1. So this condition, you have to find what is c. So you have to find the value for the constant c here. So you have to substitute the given condition y0 equal to the negative 1. So means that x is equal to 0, y is equal to negative 1. So 1 over 2y square will become 1 over 2 multiply negative 1 the power of 2. 1 over 2 ln 1 plus 0 square plus c. 1 over 2 multiply negative 1 square will become 1 over 2. 1 over 2 is equal to 1 over 2 ln 1 plus 0. So ln 1 will become 0. Multiply 0 plus c. So therefore c is equal to 1 over 2. So don't forget to substitute back c into the position of the general solution. So therefore 1 over 2y square is equal to 1 over 2 ln 1 plus x square plus 1 over 2. Okay, so if you have to simplify more, means that you have to multiply with 2. So multiply 2 for the whole thing on the right hand side. Multiply with 2 will become 1 over y square ln 1 plus x square plus 1. Okay, so either one will be accepted.